Hey guys, in this video we'll be assembling the input multiplex board for the Reproduction Mark-8 mini computer. If you would like to follow along and build your own Mark-8, there are still PCB sets available for sale at www.kalinchuk.com. This board is fairly simple and only has a few components. Unfortunately, it also has a few original bugs and fabrication issues, specifically in the earlier versions of this board. As with other boards, we'll be following the parts list on page 4 of the construction manual, the parts layout sheet for this board, which is on page 35, and the bug sheet on page 46. We'll revisit this sheet later in the video. But first, let's fix some fabrication issues. If you have an earlier version of the board, there are two issues that need to be resolved. The first one is the right jumper hole that was not included during fabrication. While we can solder a jumper directly on the trace, I'd rather drill a hole for it. I'll use a number 60 or 1mm drill bit for this. The second issue is a connected trace that should not be connected. Pin 20 of IC1 should not be connected to the passing trace. We can remove this connection by scraping it off with a utility knife or a small grinder. The trace is no longer connected. We can test this with the continuity function of a multimeter to ensure that it's not conductive. These issues will be fixed in newer versions of the board, but if you're unsure of your version, please double check before continuing. Okay, let's start the assembly with resistors as usual. This board only has one 1K ohm resistor. Next, we can install the IC sockets. Alternatively, ICs can be soldered directly in the step if desired. One thing to note is that sockets for IC1 and IC2 may not fit into the provided holes. Some alternatives are to solder the ICs directly onto the board, since they should still fit, or use a different type of socket whose pins can be bent in order to fit into the holes, as I will be doing in my case. Newer versions of this board will have the holes spaced closer together to accommodate a variety of different sockets. The connectors are similar to the connectors used in the other boards. The bottom connector is comprised of 3 10-position Molex connectors and one 11-position Molex connector. There are also 4 8-position Molex connectors, 2 on the left side and 2 on top. Additionally, we need a 1-position connector. Unfortunately, I could not find a 1-position Molex connector, so I made one out of a larger connector by trimming the unwanted parts off to end up with a 1-position connector. We'll install the capacitors next. The parts list has an error in regards to the capacitors. Here we can see that C2 is listed twice. If we look at the bug sheet point number 3, it corrects this mistake by assigning C1, C3, and C4 to 0.1 microfarad ceramic disc capacitors, and C2 to a 100 microfarad electrolytic capacitor. Let's go ahead and install them. There are 2 official jumpers on this board which are outlined in the parts layout sheet. One here and one here. We'll also refer back to the bug sheet since there is an additional bug that needs to be corrected. Point number 5 states that IC3 pin 14 must be connected to positive 5 volts. There are designated holes on the board for this jumper, they're just not annotated on the parts layout sheet. Let's go ahead and install the 3 jumpers. The last step is to install the ICs into their respective sockets. If you install sockets in a previous step, the orientation would have been considered already, but double check the orientation of each IC during installation. We're ready to test the board. I'll connect it to the same Mark-8 clone that I used for other boards and execute a couple of programs to verify that the board is operational. The board seems to work fine. The one issue that I was having was that the run cycle was not working properly. I could only single stub deprogram. I think it may be related to the temporary wiring that I'm using for testing. We'll investigate once we put all the boards together. Just a note on the multiplexers. The 8267s are hard to find, but they are available on eBay regularly. Do not use 8266s since they don't have an open collector output and will not work. The 8263s are also fairly common on eBay. If you're unable to find any of these ICs, send me a message and I will try to help. I may have some spare ones laying around. That will be it for this video. Be sure to like and subscribe so you don't miss the next video in this series where we'll be assembling the last board, which is the CPU board. Thanks for watching and bye bye.